Here's how to solve a calculus optimization problem in 4 easy steps.
A farmer has 800 feet of fencing material and wants to enclose a rectangular pasture next to a long straight river. The farmer will use the river as one side of the enclosure, so no fencing is needed along the river. Your goal is to find the dimensions, length, and width of the pasture that will maximize the enclosed area. Okay, so step number 1, drawing. If we draw this out, we have the river, and then alongside the river, the pasture. And we can say that this side and this side are length x, this side is length y. And then step number 2 is we want to come up with our equations. Number 1 is the constraint equation. And that constraint equation based on the problem is 2x plus y equals 800. And then our optimization equation is going to be area, where area is equal to xy, but we want area in terms of one variable. 2x plus y equals 800, or y equals 800 minus 2x. We can substitute that in for y, so area equals x times 800 minus 2x, or area is equal to minus 2x squared plus 800x. And then the next thing that we want to do, step number 3, we want to find the derivative of the area function, negative a equals negative 2x squared plus 800x. So that's 800. And so what is the derivative of that? Well, derivative of that gets you minus 4x plus 800. Next thing we want to do is solve step 4. And we solve this by setting the derivative of the area function, negative 4x plus 800, equal to 0. When you solve that, negative 4x equals negative 800, or x equals 200. And so that's one of the lengths. And then the other one, we know from the constraint equation that 2x plus y is equal to 800, and 2, if we substitute an x, 2 times 200 plus y equals 800, or when you solve that, y equals 800 minus 400, so y equals 400. And so the final answer, 200 by 400, are those dimensions that maximize the enclosed area.